Hey, welcome back to Power of the Programmer. This is section 5.3, and we're covering conditional checks in this section. So in the previous section, we covered print checks, printing, which is basically checking individual lines and making sure that the program still works. And whenever we find an issue, we print out what the number should be, as well as what we currently have, and then double check against it to see if it's right. So that's a good way of debugging, but the issue with that is that as programs get bigger and more complicated, print statements are very slow at fixing your code. So since we're always focused on speed and efficiency, with complicated code, conditionals is the right way to go to catch those issues extremely quickly. So if you think about it like management. Printing is kind of like micromanaging, whereas conditionals are like setting benchmarks where after a project you know that you need to get, if you're in the sales field, you know you need to get 10 leads for the day. You need to close 5 sales every week. If you're in retail, same deal. You want to get a certain number of sales. If you're in manufacturing, you want to get a certain number of products generated. If you're in teaching, you want to get a certain test grade, stuff like that. So conditionals are like setting benchmarks for yourself and your program. So if you're following along, we're looking at section 5, in the section 5 folder in the learning examples, the conditionals file. So same thing as before, I put in 5 different issues that that your job is to find them, and in this section we're going to be going through it and trying to find them. So first, let's go ahead and run it. So we can already see that there's an issue with the program. It looks like this is the same issue as before. In line 141, the date wasn't being sorted properly, so this is a off by 1 error, which is a common programming error where your loop is off by 1. Is exactly what the name implies. Basically, you're missing something, you're missing 1 iteration. So we can go ahead and remove this down. This is really common in loops because the way computers count, they always start at 0. Human beings start at 1. So that the translation gets a little fuzzy, and a lot of times you are off by 1. It's exactly what the name sounds like. So let's run it one more time and see that it works, but nothing is getting printed out now. So same as before, we have the check. So this one is conditional.txt. Let's run the diff and run it against the correct. And we can see that we have a lot of issues. So let's go ahead and see what the issues are. So off the top of my head, I can see that, first of all, the expected is everything's lowercase. So there's definitely an issue with the way our lowering function works. It is only lowering some of them and not all of them. So there's an issue with our logic there. Logic basically means code, because in the end, programming is a manifestation of the logic in your head. Logic is another word for programming. So it looks like our lower logic isn't working, and our second calculation logic isn't working. So let's go immediately and check out what is being lowered. I know the lower function is supposed to be in here. So let's run this through, and then let's start out with printing it, because this issue is more adept to printing. So let's print the state list afterwards. So let's run it one more time, and we can see that our states aren't being lowered. So where does the lowering happen? And it happens in this loop and it should be in the first one. We were setting state I equal to state I, but there's no lower function here, so we can go ahead and add that and run it one more time. Great, our states are being lowered now, but we're still not getting any output. So let's see what's going on here. Let's check where we're doing our calculation. Find average times between sales. It looks like this function is working properly. There's no issues here. So it might be in a way we're pre-processing our data. So let's go ahead and look at our data processing. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So this is working properly. So now, by process of elimination, let's go to what was happening before. And this is an example of when we can use it. So use our conditionals. So we know that there should be the number of rows in every one of these arrays. So let's make an iterator just to like double check our work. So in every count of adding data, then we can increase the iterator by 1, and then by the end of this loop, our iterator should be equal to the number of rows in every column, and every column in every list should be the same length. So we can just go ahead and double check it against one of them. So let's run it against the order ID and run it against a length. And then if it's true, then print out valid. And if it's false, then print out invalid. So basically what I'm doing here is the iterator goes through the loops. Every time it goes through a row, it'll increase by 1. And then afterwards, the order, the number of rows in every list should be the same as how many times the iterator increase. So let's run it. So it looks like it's valid. So this is actually an issue with the where place the iterator works. It should actually be placed over here, since now we're just following the logic of our program and we're not actually double checking. So now it should be actually iterator -1. So because we're ignoring the first line, and then we're also increasing every loop, every number that is greater than 1, which is the row of our section title. It should be increasing, and it should be equal to the iterator -1, because it's a number of rows -1 for the section header. So let's run it through, and it looks like it's printing out invalid now. So now we know that it might be something with the logic of our row counting. So can you see the issue? It's actually decreasing from 2, which, remember, computers start counting from 0. So it actually should be less than 1, because the first row is our section header. To simplify this logic, we can go ahead and make it equal to 0 to just straight up ignore the first row. So let's run one more time, and now since we took out the iterator, we can add it back in, and now it's printing out valid. So we can see that our program is working now. So at least this section is working now, but there's still an issue with our counting. So let's take another look and think about this. All of our numbers are 0, and our numbers should be, if we run the conditional against correct, it should be 90, 18. At least the states are correct now. So that means that our other functions are working properly. So now that we have this, we can narrow down our search down to where our seconds are being calculated. So over here, this is where our seconds are being calculated. The find average time between sales, and let's see what it relates to. It relates to the date, so the date needs to be right for this function to work. and the stuff in the function needs to be right. So by process of elimination, let's go one by one. So let's check out the dates first. And we can see that the date is being set to the datetime, and the datetime converted from the string. So that looks correct. So now we should double check if the dates are being set properly. So let's print out the dates before. So we can see that the dates are being added correctly. Let's print out the dates after. So the dates are being set properly. Now let's make sure that the average time between seconds function is working correctly. So now that we're in the average time between seconds function, let's check out what is going on here. So print the date. It looks like the date is still being put in correctly. Let's check the seconds after the calculation. It looks like it's being set to 0. So now let's narrow. Now that we have everything narrowed down, so we know that someplace here in this little block of code. So there's only two options. It looks like the seconds aren't getting anything correctly, so by process of elimination, we know it's in this section. So over here, the deltas are what determines the seconds, and what we're doing to the deltas is we're minusing the date I by the date I, and then we're going to be adding that into each second properly. So we should double check if the deltas are correct. So let's use a conditional here. Or let's first print out the deltas just to see what's happening. So it looks like they're all being set to 0. So let's just double check by running a conditional. So the date I minus 1, the date I 1 minus the date I 0 should be equal to the delta of 0. Remember, this is the logic basically of what we're doing, but we're only taking one random sample out of it just to check it. So if this is true, then it's valid. If it's not true, then it's invalid. So it looks like it was not referenced, deltas, not delta. So it's invalid. So this means that our logic here is broken. So let's go ahead and look over here. Can you see the issue? It's date I minus date I. So the same, if 2 minus 2 is always 0, 3 minus 3 is always 0. If you have a list of 1, 2, 3, 4, and 1, 2, 3, 4, if you are minusing the third number from the third number, it's always going to be 0. Whatever number minus itself is always going to be 0. So this function is missing a +1 to get the difference of deltas. So let's go ahead and run this one more time. It looks like it's valid now. So we can remove this, and now we can run this condition, run the difference one more time, and we see that it's correct now. So in this example, we looked at 3 different types of issues. I thought it was 5, but I guess it was only 3. We might have changed multiple issues on the same go. So there were 5 issues in this program, and we fixed those 5 issues using a combination of conditionals and print statements. So in the next section, we're going to be covering PDB, which is an advanced form of debugging. It stands for Python Debugger, and what it's used for is more complex issues that can't be solved or might take too long to solve just at a glance or using conditionals and print statements. 90% of the issues can be solved using these 2 methods, but the Python debugger is a good tool to have in your arsenal because some issues are very, very, very hard to spot, and the debugger lets you go over line by line like a fine-tooth comb. In the next session, we'll be covering this, so let's get started.